I'm Helen Czerski, and welcome to the Fully Charged Show podcast. One of the best things about Fully Charged is that we've got the freedom to roam across such a wide variety of subjects. It's a proper smorgasbord, all generally related to electric vehicles and future energy. And when it comes to transport, it's not all about the cars. Some of our most popular episodes, and I think they're some of the ones that excite me most, are about non-car transport. And I think it's amazing that things like electric ferries and battery-powered planes and solar-powered trains, I mean, that all used to be in science fiction books, 20, 30, 50 years ago. And they're not there anymore. They're actually here. They're popping up all over the place like mushrooms. And so here at Fully Charged, we are keeping a close eye on them. Things are really happening in this area. And it's not just talking and ideas. There's plenty of stuff that is being built and used. Today's podcast is one of my favourite sessions from Fully Charged Live 2019. And we really got into the nitty-gritty of electric planes, trains and nautical vehicles. I was joined in the Mega Theatre with our fantastic panellists Iain Gray from Cranfield University, Gillian from Viva Rail and Anna Kloppenborg from New Electric. And to everyone who's listening, we'd like to thank you for your interest and support. The people who keep track of the numbers here think that there are about 25,000 subscribers to this show, and we're all really grateful for your enthusiasm and attention. So thank you.
We're all here for electric planes, trains and nautical vehicles, not quite ships or boats, but nautical vehicles, which sounds very exciting. And to help us discuss this, please welcome our three panellists, Iain Gray, Gillian and Anna Kloppenborg. And this is a topic I'm really interested in for lots of reasons. And one, because we think about electric cars a lot. When people think about battery-operated vehicles, the car is normally the first thing on the list. But actually, that depends on a lot of individual choices. And there are some, in theory, you'd think, oh, well, there must be big, easy wins if you change the train or you change ships, right? Then lots of individuals don't have to do anything and a big system sorts it all out. Wouldn't that be nice? Might not be that easy. The other reason I'm interested in this, actually, is that last summer, when I was working in the high Arctic, we took the first electric skidoos to the North Pole. Specifically to reduce pollution so we could do our experiments. And that was a scientific necessity. It wasn't because everyone was into EVs. It was because we couldn't have the pollution. Let's start with Alice. Let's start at that end. Tell us a little bit about your bee.
Hello, I'm from Viva Rail. We're the country's newest and smallest train manufacturer. And we're the only ones who's built a working battery train that could run a passenger service today.
This is turning into a popularity contest already. All right, Anna.
Well, hey, Anna Kloppenborg, New Electric. The very first thing I did in the electric world for myself was to show that we can go water skiing with an electric water ski boat. At the time, sustainability was turn off the light and be ashamed. And I just wanted to make sure that it's come join the fun. And actually, we can take the fun on the water, too, whether or not it be high volt. So from there, we went on to do commercial stuff, and by now we're trying to replace tugboats and big diesel engines with electric power.
So conversion, and you may remember, any of you who watched, there was a Fully Charged show a few months ago, was it?
I think it went live in January, and it was a beautiful September day that we did the filming.
Robert and Johnny basically went, there's this beautiful wooden boat that was converted, and they were zooming around the canals, having an enormous amount of fun. But you'll have seen Anna there. And Iain, tell us a little bit about your expertise.
So I'm Iain Gray, Director of Aerospace at Cranfield University. Cranfield, the only university in the world with its own airport, its own runway, its own air navigation service provider. And what a great place to do research around electric aircraft. I mean, it's amazing just walking through the halls here. About 10 years ago in a previous role, I could see the automotive sector starting off around research, went through research, demonstrators into full-scale production, and now we see the results of it. Aerospace is at the start of that journey, and it's a paradigm shift in terms of not just the airplanes, but the way we transport people and freight around. So it's a really exciting time to be part of the sector.
So let's just start off by talking a little bit about the challenges of doing this, because you know, in a car we're used now to seeing that you can just put a load of batteries and a motor and it attaches to the wheels in a car and it just seems to work. And as long as you can charge it, you're all right. But for each of these three things, for rail and boats, I know you convert other things, and the aircraft, what does this work? Can you just shove a battery in it? And what about power to weight ratios and all of that? Who wants to go first on that?
Well, I'm happy to go first on that. And I think for me, a key message around aviation and aerospace is that there is not a one-size-fits-all model. And you know, if you look at electric aircraft today and you look at it from a drones perspective, you look at it from a general aviation perspective, you look at it from an urban air mobilities perspective, we're starting to see electrification. It's doable, it's possible. There's some regulatory hurdles, there's almost definitely some infrastructure issues that need to be addressed, but it's doable within a 5-year time frame. If you start to go beyond that into regional, sub-regional, regional aircraft, it's potentially doable, 50-seater aircraft, say in 2035, by 2035. That's possibly doable. But there's a lot of research and technology needed to get there. If you're thinking of the aeroplanes that go beyond that, actually there's some enormous challenges. And I sense we're not going to see that in our lifetime. So let's kind of think of the aviation market in different sort of segments. And let's take the excitement of urban air mobility, general aviation and drones, and let's move that forward as a pathway for regulation and infrastructure.
So let's just explore, because the issue with a plane, I mean, the benefit of jet fuel, for all the bad things about it, is that you have to get it up in the air, but then you burn it, so you have less and less and less, and so you land lighter than you started. But with a battery, you land at the same weight as you started, right? So it's not as simple as that's, you know, why is long distance travel so much harder?
Well, I mean, range anxiety in a car is an issue. Believe me, range anxiety in an aeroplane is a fundamentally different issue. So, you know, getting batteries that can do what you've described right is great, and it's really good that the aerospace and aviation sector is learning from the automotive sector. You know, we had Dave Greenway up talking a few minutes ago, Warwick Manufacturing Group, and all that work that's going on around batteries can play a part. But from a certification point of view, you're right. I mean, an aeroplane, the regulatory approval is based around 100 years of history, and 100 years of history with avgas and aviation fuel, you burn that as you fly around, and if you have a problem in the air, quite often the airplane might dump fuel. So the principle, the aircraft lands at a very different kind of weight to the one it's taken off from. Arguably, in some forms of electric hydrogen kind of aircraft, the landing weight may actually be bigger than the takeoff weight, albeit just marginally. So there's a whole different psyche, a whole different way of thinking about how we do things. So it's not just about the battery technology, it's how the battery technology is integrated into the platform, how the thermal management system works, how the power management system works. And I guess it goes without saying as well, automotive is about volume production. There's an emphasis around cost. Aerospace, there's a huge emphasis around weight, getting the weight down. And so you might have the chemistry of the battery fundamentally right, but the cell pack and the way it all comes together has not been optimized about the needs from an aviation perspective. So,
and Anna, you're into converting things. So you take existing vehicles that did not start life with a battery in them. What are the challenges associated with that? Is it easy to do? I mean, you've got to work with a lot of, you can't design it from scratch, right?
Well, absolutely. Look, if you're going to convert it, and just to come back to the original question, I mean, I definitely believe batteries in an electric motor, they're a solution looking for a problem. And in general, I do believe, and especially with iteration, we can actually make everything better than it was in its combustion counterpart. Chemical rockets are going to be a challenge, but hey, we're going to get there anyways. if you're going to convert an existing vehicle, the design envelope is there. The vehicle was made over many iterations, many generations of thought, generally to do a specific function. And again, the size and shape and weight of anything you're going to put in it is going to affect the thing. And especially a boat, it's like an ecosystem unto itself. Prop dimensioning is not it's as exact as a science that you'd want it to be. Basically, you need the physical boat at its physical weight, and then just try different things. Now, for converting stuff, especially in the marine environment, I do think it has a very important role to play, because the marine environment already is one where it has so many niche designs, so many niche solutions, that to wait for large-scale volume and affordable volume and certified volume of replacement of those existing ships to be made are meaning that we're going to wait too long, it's going to cost too much, and we're not going to solve the problems in the time frame that we have. And then from an energetic standpoint, having all that energy already invested in the individual shape of the individual boat that can do its function, why would you throw that away instead of just saying, hey, let's pick out the diesel? One of the advantages we do have from a mind frame perspective of the nautical environment is that oftentimes ships already get repowered a few times in their lifetime. A car or a truck is generally written off as soon as the engine becomes untenable from a maintenance perspective, whereas a ship already has too much value and function to say that we're going to throw it away just because the propulsion unit is outdated. You're going to repower it. Well, let's repower it again, just the next time it'll be electric, and that'll get our time to market up, and it'll actually make the environmental benefits start happening sooner than waiting for a factory new vehicle to come along.
And I think, just as an example of how, because you would think a ship, you build it, you're not going to get back inside it. There was a ship at a research institute I used to work at where they bought it wasn't long enough, so they cut it in half, pushed the two sides apart, built a whole new middle section, and basically had a new ship. And that was normal, right? Because it is so valuable, so why not just rebuild it from the inside? And how about trains? When we've all seen kids' trains, they've got little batteries, they scoot around fine. What's the situation with batteries and trains?
Well, the train is basically looking for power. So ours is looking for 750 volts DC. And it doesn't mind where it gets it from. We've built our first unit as a diesel unit, and that runs it. And then we built a diesel battery hybrid, and now we've got a pure battery train. The way we see the train is moving forward with batteries. So we'll always have 2 battery end cars, each housing 2 batteries themselves, and then use anything else as range extenders. So that can be a diesel genset, and that will be basically primarily used to charge the batteries, not to power the train. You can have a pantograph to take use of electrification where it's happened, and we're also working on a hydrogen fuel cell version as well.
So what's the situation now? And this is a question to all of you. Like today, how many electric trains are there? How many conversions have you done? How many electric planes are in flight?
Electric trains, hundreds, because the network was electrified. Battery trains, 1, ours. And the problem has always been, it's the range and the rate of recharge. Because we all know how long the line's going to be. We can all model it, but you've got to meet that service pattern. And if you can't recharge the batteries fast enough, the train's just commercially not viable. So for us, we've developed a fast charge system as well. Very simple, and it basically involves the train pulling to the terminus, connecting with some conductor rail, charges up in 10 minutes, and off the train goes back into service again. And that's what makes the train viable for today.
And is this in service now?
No, it was launched last year, and it hasn't got a buyer yet. It's available.
Anybody would like to buy a battery-powered, full-size battery-powered train? This is the woman to talk to. And Anna, how about conversions? How's that going?
As it comes to ships, actually, and it's kind of like in the train world as well, there is a certain class of ship, a certain class of train where actually it had been pushing electric technology long before that we all kind of got into the game, say the last 10 or 15 years. In the megawatt plus class of ship, in the largest cruise ships that are out there, all the pods are generally already electric propulsion, because that concept that the torque at low RPMs works better with an electric motor has been around for a long time. Generally only they would work from large-scale generators and doing that kind of thing. Now in the megawatt plus class in Scandinavia, and you guys have been on them, and there's some of these huge ferries coming along. Now it's in the smaller, definitely in the private class ships and in the planing hull ships where a lot of that new technology is going, because we need that Tesla class of power to weight and energy to happen for a hull to be a planing hull and to have that be sustainable. Us ourselves, I mean, we're a small upstart and we're trying to shame bigger boys into doing more work. So, it's not that we've solved the world's problems yet with the amount of ships that we've converted. Let's call it about probably, say, 15 or so we've done ourselves, and probably another 30 or so systems we've put together in a crate and helped others do. But once again, we want to be pushing the envelope, want to be showing it can be done. And by now, because we've actually developed solutions for a certifiable working market, what we like to call diesels with a job in town, and replacing those, we're seeing an uptick. So we're finishing the second tugboat. We've got orders for another 3. And we're getting questions from a lot of different interesting places in industry, even for some offshore stuff, because it just doesn't look so good anymore when you're doing a big wind farm, but you're shuttling people around in your big diesel tug, So there's a lot of that happening, and it's mostly about looking forward and doing more in the future.
And I've also seen quite a lot of, so I think that the plug-in hybrid is a kind of intermediate stage. So the Thames, the Port of London Authority, their next tugboat will be a plug-in hybrid, because they want to push towards electrification, but they know that if they have to go, they want the backup of having a petrol engine.
From a pragmatic standpoint, if you are just charging your batteries with a diesel generator as opposed to doing propulsion straight from a diesel, that's 40% reduction in actual liters burnt and 60% reduction in actual soot and fine particulate matter, which matters because that's the stuff we're breathing. So already there, from a pragmatic standpoint, let's have that hybrid phase. We've built a parallel hybrid version where you can still run on the diesel, but I like the series hybrid better, because right now you'll put a modern diesel generator in there, and one generation down the line, 3 to 5 years, that same volume and weight can be your hydrogen generator, your fuel cell stack, and we're working towards that goal as well.
Okay, so Iain, planes. Where are we at with planes?
Well, it's a massively exciting time. As I said at the beginning, you need to think of this in a market segmentation point of view. And if you look at the really exciting developments around urban air mobility and general aviation, I think at the last count was something of the order of 170 different designs and principles that are out there.
Let's just say a little bit what urban air mobility is, because that's one of those words that gets thrown around when you're in the inn, but not everyone may know what that means.
Well, I mean, urban air mobility is a transformational way of thinking about transport. It's about using vertical takeoff air taxis is a term that some people use. I don't particularly like that term. And flying them from point A to point B within a city or or a kind of urban area. And it's seen as a real potential growth area. And that's where most of the development and technology is happening at the moment. As I say, there's not a week goes by without some news going on. I mean, Lilium had their maiden flight of their 5-seater just about 4 weeks ago. We've seen just in the last week Vertical Aerospace, a company in Bristol who I think work with Warwick Manufacturing Group, who have just signed a big deal with Honeywell Systems to move things forward. We have in the UK in September at Farnborough the very, very first urban air mobility show. So in that kind of segment of the market, there are things happening, and I would suspect on a week-by-week basis we will see news. If you start moving up into the regional aircraft market, 50-seaters up to 100-seaters, then we're in the demonstrator kind of phase. You've got things like Airbus and Rolls-Royce working on a demonstrator project called the EFAN-X. It's demonstration of technology rather than product. And if you look at the bigger aircraft than that, well, we're back, long way back in the research labs and looking at sort of cryogenic engineering and looking at real far-fetched technology and research level, and we're a long way out from that. So a hugely exciting time in that particular segment of the market.
So is the biggest thing holding all of this back battery technology? Because we hear people like WNG, these great sort of gains, improvements in batteries, but they're kind of like, this is not like the days when the iPhone first came along and every year there was a doubling in capacity or a doubling in memory. They're really important improvements, but they're little bit. They're not taking you that far, miles over there. Is battery tech holding this back, or is it power management? Are there other things? Even if the batteries don't get that much better, is it still going to happen?
So from my perspective, there's some huge developments around batteries happened in the last 10 years, but they've been driven by the kind of criteria that's important in the automotive sector, not driven by the criteria that we need for the aerospace sector. Potentially, the battery chemistry itself is still good, but the pack in which we put the different cells all together has been optimized around a different set of criteria than that aviation needs, where weight is everything. Weight is really critical in aviation. And in that segment of the market where things are happening, that's what's happening. It's the integration of batteries using today's chemistry, but structured, put together in a way that are more optimized for the aerospace business. But in terms of things holding things back, do not forget the power of regulation. Do not forget the importance of infrastructure. We've seen in Norway a statement that by 2040, all internal flights, short-range flights will be electric. A statement like that can be a massive driver to industry to respond.
I'd like to jump in on that point exactly, because I mean, sure, there's the laws of physics and a cost of battery, aspect to it, and if you can't make the plane fly far enough on the power to weight ratio, you're not going to get there, and it won't happen. But absolutely, I believe that it's not only the regulatory, desire, the personal desire of folks like us that are interested in it to push it forward, but it's the wherewithal to be honest about the sweetheart deals and the not priced in costs of that which is actually polluting our environment that is really holding us back. I mean, the reality is that in a tugboat that I recently built, we went and it does still have diesel on board, and that diesel was being pumped in at 40 euro cents a liter, whereas all the other industry has to pay €1.50 a liter for the normal pricing of diesel. And it's that same industry that's crying out crocodile tears for the fact that we would be, in some way, dare we be supported by a grant or that kind of thing? It's a sweetheart deal for industry that is not only being subsidized in its pollution, but also not having to pay for its own solution either, the tragedy of the commons. Once you say, we're not going to subsidize individuals, but we're going to say, if you want to come into our fair town and make a buck in our fair town, it's going to be environmentally sensible, or it's going to be not at all. And none of this, exemption because you weren't able to buy it. None of this, why would you invest if your competitor is laughing all the way to the bank because the cost of his pollution is not in his product?
And California's been very good on this for vehicles, right? They sort of pushed a load of regulations and just said, sod you, you're going to do it. Yeah. And it did push things along. And how about in trains? Like, what are the obstacles? Is it the battery technology, or is it other things?
No, it's actually quite different. With the trains, we know the space envelope, we know the distances, and we know the power output, so you can calculate everything back. There's also a political will. Diesel trains are supposed to be phased out by 2040. But electrification is so expensive, and there's huge swathes of the country where it's just not going to happen. And this is where battery trains have their part. But it is going to be getting those first ones into service and proving it. Now, you can run demonstrators, everybody can do that, their first prototype vehicle, but it's got to be actually seen working. The way we see it going forward is we've got the country's first diesel battery hybrids going in to transport for Wales this year. That will prove that you can run a battery service over a decent amount of distance. It's reliable and it can be done. So, that's all I'm hoping for, that the political will keeps building and everyone starts moving on to emission-free trains, which are extremely possible today.
So let's open it up to the audience to hear questions.
Hi, thank you. On ships, we saw a show just recently where they showed a car ferry that was doing about 10 miles, I think. Projections about how long it might take to get to, say, 100 miles, which would then do the UK to Ireland. What do you think?
Realistically, if you look what's available now compared to 5 or 10 years ago, the only thing that you know for sure if you're going to predict the future is that you're going to be off by a certain margin. But I would say that, especially in those kind of things, it really is more of a cost analysis as competing with other operators in the same seas and that kind of thing. I would say that another 5 or 10 years, look, generally, I think all the 2040 and all the 2050 targets, they're far enough away that we feel we can sit back and relax and wait for it to happen. As soon as you start talking about, like, well, let's put a 2025 target on thing, everybody gets so angry because it can't be done and it shouldn't be done. So I think it's in part that we have to be honest that it's our own emotional responses to things that are holding things back in that sense. Personally, I think doing 100 miles on the ocean at 10 kilometers an hour, if you would accept that you would have some less passenger capacity if you're retrofitting the same ship, if you would accept that you're outlaying money, but you're getting preferential access to your permit to be allowed to do it by the political, powers that be, then I think it could be done within 3 years. Realistically, I think we're looking at 5 to 10 years for the exact scenario that you're talking about.
And bear in mind as well with the ships that they're already optimized. They don't travel as fast as they could. They're very careful about their routes. They're already optimized to the rules they have. So they're just giving them a different set of rules to optimize towards. If you accept a cargo ship taking 6 weeks instead of 3 weeks, things get a lot easier. And at the moment, they work entirely on fuel consumption. That's their gold standard, right? Because it's expensive. So you shift that and you shift the rules and you shift the game. Okay, anyone got another question?
Hello. Question for Iain. Do you feel that synthetic greenhouse gas neutral fuels, if they exist, can play a role in aviation? And are you hopeful that that might result in significant reductions in emissions? Is that a realistic scenario?
So you're saying synthetic, so biofuels and things like that?
Yeah, not necessarily bio, but greenhouse gas neutral fuels. Is that pie in the sky, or is that something that is a possibility?
I think the subject that we should be talking about in the broader community is around zero emission. And zero emission is much, much more than just electric. I think hydrogen should be in the mix. I think hydrogen's kind of not been talked about too much in the last few years, but I think hydrogen should be in that mix. Biofuels, we've clearly got to look at the environmental considerations in the overall round about biofuels, but I think working with the fuel manufacturers, there's a real need to look at that in the long term, in the long range aircraft market. Coming back to my market segmentation point, my point would be in that smaller general aviation, urban air mobility, I think electric can be a solution. I think in the mid-size, some kind of hybrid solution may be the solution. But when we want to travel long range, then we need to start thinking about zero emission in a slightly different way. And so I totally take the point. And I would love to see in the UK a much more active research programme around hydrogen.
And so someone told me something recently about planes, which was that most of their engine power is to get them off the ground, and that there might be potential for using a battery to help with that bit of extra boost. Is that a viable thing? You could have a hybrid system that gives you a little bit of extra oomph, but you're still flying mostly on jet fuel.
I mean, I think a hybrid system where you're kind of optimizing the energy combination for different parts of the flight. My background was in aerospace, conventional aerospace. There was nothing that would frustrate me more than spending 5 years trying to optimize the weight of an aeroplane down to the very last sort of gram, only to be as a passenger spending 20 minutes floating around the air around Heathrow in an air traffic problem. So sometimes these problems don't lie in the platform itself. They lie in the ecosystem in which the aircraft are flying. And I think when we start to look at zero emission, we need to think much more broadly than just the platform itself. So I take your point. I think it's a great one about a re-optimization of different energy contributions in different parts of a flight cycle. But let's look at this from an overall system point of view.
Okay, any more questions? We've got time for one or two more, I think. Yep. Yes, down the front here.
Hi. With a short-haul aircraft, What sort of percentage of the energy could you save by launching it with a glider winch?
By launching, say that last bit again.
By launching it using a glider winch.
Oh, glider. I've flown in one I've flown in one that did the other thing, that took off using a battery and then became a glider. But could you launch using a glider winch, aircraft carrier style, but backwards? Could you do that?
We should not dismiss any kind of ideas. I've certainly been involved in projects loosely described as landing gear of the future, which do not look like the landing gears we see on an aeroplane today. Do we, jettison a landing gear after takeoff? I think we also, however, need to be kind of pragmatic and realistic about where these things take us. Ground operations is a significant part of the fuel burn contribution of an airplane today at a busy airport, and looking at alternative solutions when that airplane is on the ground is a key thing. Carrying around a landing gear, which is not required at all during flight, but believe me, as a passenger, you're pretty grateful is there when you come in to land, is a dead weight. Is there a better way? Is there a different way of doing it? But we need to be pragmatic and realistic about the different solutions we look at.
I think we've got time for one more question.
I'm sorry. I'd actually like to come in and have a quick question for Alice. Sorry to say, but I'd been recently contacted by a Dutch public transport company that does a lot of the underground rails, so the rail, but subways as we know them. Now, when the rail breaks down underground, they actually have an air-cooled trail system that goes in because they wouldn't have electricity. It just broke down. They go in. And they asked us to do a system design for them, which we did. They really liked it, but they had to get competing quotes, and no other company could give us a competing quote at all. So could we actually send you the specs, and would you be able to do a competing quote for an underground rail system? Would that be something? 'Cause I'd love to have you guys get the job or have it done at least.
Yes.
What kind of power levels do you work at anyways?
Should we talk after?
Let's have it done.
When it happens in 10 years' time. You were here when it started. Okay, one last question from the audience. Yes, in the middle over here. Where's our microphone gone? I can't. Oh, you're over there.
Hello.
Oh, no, got one over here.
I've got the mic and I'm going to use it. Is there a market segment and an opportunity to use airships for electrically powered flight?
Almost definitely. I mean, the UK has taken a lead in a small company called Hybrid Air Vehicles, and Hybrid Air Vehicles has working, as I understand it, with WMG and with a number of battery integration providers, is looking at using that hybrid air vehicle for exactly what you've just described.
So the skies are going to look very different in the future. I think that's what we've learned. Right, we have very sadly run out of time. There is clearly loads to say. I'll have to persuade them to have 3 separate sessions on these 3 transport systems next year. Please join me in thanking our fabulous panel, Iain, Alice and Anna. Thank you.
Thank you to our Patreon supporters, because without your support we wouldn't be able to do these podcasts, the Fully Charged live events, our Patreon-only events, or even the YouTube channel. So if you're interested in joining that wave of support and becoming a patron on Patreon, follow the links in the show notes. There's all the information on how to do it there. And if you've got a couple of seconds to spare, we at Fully Charged will be ever so grateful if you leave us a 5-star rating and review on whatever podcast player you get these podcasts from. The reason for that is that it helps other listeners find us, and if you, the audience, say it's all right, then it must be all right, and others will follow your recommendation. And finally, don't forget to subscribe to our 2 YouTube channels. There's the main Fully Charged one, which you all know and love, and there's now also Fully Charged Regen, which will have lots of behind the scenes stuff and fun, little nuggets of stuff that are additional to the main episodes. And it also has all the talks from Fully Charged Live 2019 in video form, so you get to see the faces that everyone was making as well. As always, if you have been, thank you for listening.